So I worked on my power supply again, and I know probably at work Hashem's going to make fun of me when he sees this, but what I have set up here is I have my smaller, easier to use Saley logic analyzer set up to monitor some debug pins and master clear here. So I upgraded the firmware in here to use an RTOS. I'm using OSA RTOS. It was built by a guy, or a couple of guys, maybe some girls too, I don't know, in I believe Romania. And I upgraded it to that because it was fun, and it's also a lot smoother on updating the LCD. And I also did oversampling and decimation of the samples to get a 10-bit ADC turned into a 13-bit ADC using 64-bit samples, or not 64-bit samples, 64 samples accumulating to decimate. And in order to speed it up, I found that overall, with a polling architecture or anything else similar to that, it was really slow. The RTOS sped that up, but I ended up actually down here soldering a bridge across 4 or 3 more analog channels for the ADC. I don't know if you can see that very well down there, but I'm pointing at it with my yellow parts picker thing. So in here it's now using 4 ADC channels, and it's reading all 4 ADC channels at a time, causing it to only need to make 16 read passes before it does a oversample decimation to give me a value to read. So that's happening, and I also have an idle task that is counting the number of messages sent, the number of messages received between the two tasks, and making sure that it records if it lost any, as well as I think OS errors and possible event errors that can be caused by messages not being received right or not being sent correctly. I don't have those printing out. I don't know if I'm going to actually add a button or maybe an NRF 24L01 plus radio, and then build some kind of radio receiver for my computer or something to receive it. I don't know. This seems kind of wasteful. But at least when I'm debugging, I can stop and look at the structure to see if there's any errors or missed messages. So it boots up pretty fast, even though it takes a second while it displays the firmware and power supply, the version number or whatever. So I'm going to boot it up, and you see it comes right up with power supply, and it reads the voltage, and it reads the voltage and displays it in millivolts as well as volts, and it's quite fast, catching up with the 10-turn pot really quickly. And this is still, it's catching up this fast while taking 64 samples and decimating it, and then doing the multiplication to get the actual voltage values in real time. I mean, this isn't, my tick timer is like a millisecond, and it's still pretty accurate too, which is really cool. So when I turn on the output, you'll notice it says 124.8. Over here on the voltmeter it says 1.242. A little off, I don't know. But if we turn it up to like 3.3, common voltage for most electronics nowadays, we're pretty close. I mean, I would call that 3.3. 3.297, 3.286, still 3.3, 3.29. Good enough, right? Horseshoes and hand grenades. Get it right on the 5 as well. 10-turn pot's pretty cool. So that's pretty much 5. Goes all the way up to 9.97. So it's really stable. Barely flips even when it's kind of like on the border. And then if you just give it a little bit of a tweak, it still really doesn't flip around too much. So all in all, I think I'm pretty satisfied right now with it. Didn't take that long, a couple of hours, play with the tasks, play with the messaging. So yep, that's it. If you go to my blog, there'll be a picture of the actual output from the Saley Logic device that shows me shows what I use to debug the startup of the RTOS and the application. Had some problems at first, so I had to set up a bunch of debug pins, and then some still pictures of you know, this. So until next time, bye.